Today we'll look at tips for improving update survivability and robustness. We'll begin with a brief presentation reviewing commands in the IPart, FEM, and SIM that are associative, as well as some that are not. Then I'll demonstrate how to idealize a hole with a mesh point and apply a load to it that will survive an update. Let's first review the file structure of our simulation parts, beginning with the master part, which has the original CAD geometry, but the analyst may not have write access to make changes. The idealized part is an associative copy of the master geometry. Here the analyst can create a mid-surface as well as idealize the geometry. Next we have the FEM, which is where we can create a mesh and assign physical properties. And lastly we have the SIM, where we can create loads, boundary conditions, and set up our solution. In the IPart, most commands update, but some don't. Any feature created that lands in the part navigator will update. Mid-surface, split, and trim all update, but we need to be careful when creating points. Make sure associative is toggled on in the settings. Any command that does not land in the part navigator will not support a robust associative update. In the FEM, we need to be more careful to ensure survivability. In general, commands that select polygon geometry or selection recipes will update, and commands that select finite elements and nodes will not update. One command to be careful of is stitch edge. If the method is set to automatic, the stitch will update, but if the method is set to manual, it won't. In the SIM, commands that select polygon geometry and selection recipes will update. However, if those same commands select finite elements and nodes or mesh points, they won't update. For the demonstration, we'll be using a sheet metal bracket with some primary mount holes, a secondary hole, and a lightning hole. We're going to create our simulation files, also requesting that we use points that are created in the idealized part and the master part, and we'll create a nonlinear static solution and take the defaults. So we'll begin in the idealized part, where we'll get an associative copy of our geometry. And next I'm going to unite the gusset into the main bracket, and this is important if we want to have the gusset mid-surface extend into the mid-surface of the main bracket. So now that I've united it, when we mid-surface here, you'll see that that gusset is extended. Alright, next we'll create an associative point at the center of our secondary hole. Alright, that's an associative point. Now we'll go to our FEM and we'll bring in our mid-surface. Now to ensure that we get a congruent mesh across all of these bodies and faces, we're going to go ahead and stitch. And we're going to make sure that we're using the automatic method, which will ensure a robust update. So here you can see the stitched edges in cyan and the free ones in magenta. Next we'll go ahead and create our mesh, and for the mesh recipe we're going to make sure that we're suppressing holes that are less than 3/10 of an inch in diameter, which will capture that secondary hole where we have our point, and we're going to put an additional point, but a special one that's called a mesh point, and that's going to drive a node to that location. So here, if we hesitate, we'll see that we have both the point in that location as well as the mesh point. Next we'll go to the SIM, which is where we'll create our load, but first, to ensure that that load is going to be associative, we're going to create a selection recipe to capture that node at the mesh point. And it'll be a proximity selection recipe that will look for nodes within 1/1000th of an inch from our point. Not our mesh point, but our point. All right, now we can create our load. And for the object to select, I'm not going to pick it off the screen. It's the selection recipe that we're going to select. And here you can see now we've got one object selected. That's our selection recipe. And that will ensure a robust update. So now we can go ahead and try to solve, but we had our solver setup check on, which found that we didn't put any constraints on the model. So let's go ahead and put some fixed constraints on our primary holes. And we're going to make sure that we select polygon geometry. Here I'm selecting polygon edges. That will ensure a robust boundary condition there. Now we'll go ahead and solve. And this one doesn't take any time at all to run, and we'll take a look at our results. Here we'll just look at our displacement results, and we can animate those that show the bracket twisting under our 1 pound load at our secondary hole. Alright, so let's go ahead and test the robustness of our bracket simulation model by moving the location of our secondary hole. Alright, now that we've made that change, let's go take a look at our idealized part. Here you can see the mid-surface has updated. We can go to our FEM. You can see that the polygon geometry has updated and our stitch recipe has updated as well. All we need to do is update the mesh, and you can see that our point and mesh have all updated. Also, we can see that our load is also updated in our sim. Now, before I go ahead and do another test solve, I'll go ahead and clone that solution. We'll call it 101A before we go ahead and solve. So that way we can view the results side by side with our original. Alright, so here we'll go ahead and first open our displacement results from our original run, and then we can put in our displacements from our updated run below it in a top and bottom view, and we can animate those results as well. Following those tips will ensure a robust update every time.